Welcome back, grade 7 and 8, to another one of Mr. Wensing's science videos. Chemical reactions are a very important part of the food we eat. The energy in all of our food can be traced to photosynthesis, a chemical reaction that occurs in plants. Ripening of fruits and vegetables involves many chemical reactions, many of them with oxygen as a reactant. And the preservatives and flavorings in food are all based on chemical reactions. For example, 135 reactants are involved in the chemical reaction that produces artificial raspberry flavoring. Understanding how fast chemical reactions happen is important. For example, food chemists must know how long a preservative is able to preserve a certain food. The reaction rate is a measure of how rapidly a reaction takes place. It is calculated by figuring out the amount of reactants that remain after a certain period of time. Reaction rates vary widely. Some, such as burning, happen rapidly. Others, such as rusting, may take years. To understand the speed of chemical reactions, it is necessary to understand the two conditions that must exist before a reaction can take place. First, the reactant's particles must come in contact with each other. Second, this contact must occur in such a way that the various particles can bond with each other. Thus, changing the conditions can change the speed with which the reactants contact each other and form a chemical bond. In other words, changing the conditions can change the reaction rate. 5 factors affect the reaction rates. Temperature. Often the easiest way to change the reaction rate is by changing the temperature of the reactants. Lowering the temperature decreases the reaction rate, and increasing the temperature speeds up the reaction rate. For example, frying an egg is a chemical reaction. Frying an egg on a low stove setting takes several minutes, but frying it on the highest setting takes only a minute or two. As the temperature increases, particles of the reactants move faster, colliding into each other more frequently. At higher temperatures, particles also have more energy, which allows them to bond with each other more readily. Surface area. Increasing the surface area, or the amount of exposed surface, of a solid reactant increases the reaction rate. A reactant crushed or ground into smaller fragments has more exposed surface area than one larger piece. When more surface area is exposed, particles of the reactants come in contact and bond with each other more frequently. For example, solid zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. Cubes of zinc, measuring a centimeter on each side, have only 6 square centimeters of zinc surface exposed to the acid. But grinding the zinc into powder exposes 10,000 times more surface area to the acid. The larger surface area greatly speeds up the reaction rate. Concentration of reactants. The reaction rate generally increases when the concentration of the reactants is increased. This is because there are more particles available to bond, and the particles collide more often. For example, substances such as coal burn much more rapidly in pure oxygen than in air because air is composed of only about 20% oxygen. Since the combustion, burning, reaction requires oxygen, extra oxygen increases the speed of the reaction. But sometimes increasing the concentration of a reactant does not increase the reaction rate. Chemical reactions frequently take place in a series of simple steps, called a reaction pathway. The slowest reaction along this pathway, called the rate determining step, determines the speed of the entire reaction path. Adding more of a reactant to one of the other pathway steps will not speed up the overall reaction. Picture the rate determining step this way. Imagine you and your friends are making sandwiches for a fundraiser. 3 people are spreading mustard on the bread, 3 people are putting meat and cheese on the bread, and 1 person is wrapping the sandwiches in plastic wrap. Wrapping takes a long time, and only one person is wrapping. So, the person who is wrapping determines the pace of the sandwich making. In other words, wrapping the sandwiches is the determining step. Recruiting more people to spread mustard or put meat and cheese on the bread will not speed up the overall sandwich making process. Catalyst. Some chemical reactions happen quite slowly and require the presence of another substance to speed up the reaction rate. A substance that increases the reaction rate without being permanently changed is called a catalyst. A catalyst is not part of the final product of a reaction. Sometimes chemists can even recover and reuse catalysts. Catalysts are common in the human body, usually in the form of enzymes, which are proteins. Enzymes can speed up chemical reactions in the human body by a factor of 10,000. For example, an enzyme in human saliva uh, acting as a catalyst speeds up the conversion of starch into glucose, so it can be digested immediately instead of several weeks later. Inhibitors. Sometimes it's important that a chemical reaction happens more slowly than it naturally would. In these cases, an inhibitor, a substance used to slow down or stop a chemical reaction, is used. Inhibitors interfere with the surface chemistry of two reactants, preventing them from rapidly bonding together. Preservatives added to food are inhibitors that slow down reactions in the bacteria or fungus that can spoil food.